Welcome, everybody, back to the Beyond the Big Bang podcast. We've heard it all before. COVID is fake, vaccines give you autism, genetically modified foods are bad for you, and of course, the earth is flat. In recent years, there has been a growing mistrust of science. And what's behind this? What can we do about it? You heard us talk about it last week, and today's the week we have a very special guest. I think he's often referred to as the king of flat earth himself. He was a of the documentary Behind the Curve. He's been a keynote speaker at several Flat Earth conferences, and he has almost 19 million views on his YouTube channel. Mark Sargent, thank you very much for being here.
Thank you very much for inviting me.
I guess we should probably introduce ourselves, shouldn't we, Hannah? So I study physics at the University of Toronto. I have an undergraduate degree in physics, and I'm now doing a PhD in computational fluid dynamics.
I'm Hannah. I'm also a graduate student in physics. I study cosmology. And for those of you who are joining us again, you might notice that our usual other two scientists are not joining us today. Gunjan and Trevor decided not to join the conversation today. They didn't feel like it was something that they wanted to speak about. And, we respect their decision to not be here.
That's the reason why we have so few, why we pick up as many people as we do, and why science has a tough time going against us, because to most people in that community, it is utterly beneath them. So why would we talk about it? It's absolutely silly. It's ridiculous. It's stupid. Why would we even address it? And to your point, by the way, your show introduction, you're saying, how can you stop or stem the tide of the anti-scientism thing? By addressing it, by having a lot more people like you trying, getting out there and doing that. Your friends, and I'm not trying to pick on them, not being here. Yeah, that's part of the problem. We created a model of the known universe that is easier to explain than the heliocentric model. And in doing so, remember, the general public, whether you agree with it or not, they like easy. They always have. You guys are in the top whatever 1% of the elite of the academic. And the general population, the mouth-breathing troglodytes out there, you know who they are? They make up the bulk of the population. And so if we show them this with all sorts of explanations on how it works, and it makes sense to them, what do you think they're going to go with? And what I try to tell people is, don't take science at face value. Science is wrong a lot on a lot of things, but they never apologize for it. They just restate things. They just reprioritize things.
I think we should be careful. Are we talking about, is science wrong, or is any particular scientific theory wrong?
There you go.
Because science is a process that corrects itself.
You're absolutely right. I forgot the audience I'm talking to here. Yes, there are certain aspects. So, okay, let's drill down that for a second, which is, you want to tell me what the boiling temperature of water is at sea level? Great, fine. I can go get a pot and a stove and a thermometer, and I can test that myself and figure out what altitude we're at. You want to tell me what the core of the Earth looks like? Oh, no, you can't, not even close. I mean, the core of the Earth is supposedly 4,000 miles down from where you are now. The deepest hole ever drilled, what is it? Is it 2,000 miles? 1,000, 100, 10? It's 8 miles. That's the deepest hole ever drilled. And in fact, in the fine print, and you can wiki this all day long, they'll tell you, it's like, oh yeah, we have no idea what's down there. We're just extrapolating from volcanoes. So, okay, why are you showing me these?
Not just volcanoes, to be fair. Not just volcanoes. We do have seismic data that tells us a good chunk about what's underneath the core, the surface of the Earth.
So those bands, those perfect 1,000-mile thick bands of red and orange and yellow and white, you know exactly what those are. No, you don't. No, you don't. And even if you could, why are you showing me the cross sections of Neptune and Jupiter and Saturn, places we supposedly haven't even sent probes to? How are you showing this?
Well, because we have methods of, we don't have to go to the sun and take a scoop out of the sun to know what the sun is made of. Like,
yeah, you do.
There are different that you do not. You actually do not, because of this process called spectroscopy, where the atoms themselves, specific atoms, have different signatures in a spectrum. They release particular types of light, and it's unique to each atom. there are transitions that release light, which is unique to all of these atoms and molecules. And so if we see those spectra, then we know what the sun is made of.
And by the way, Mark,
And
this is an experiment that you can do yourself at
yeah,
home.
you can do this experiment at home.
You just need a
Uh-huh.
spectrometer.
Yeah.
Right. So sticks and shadows argument. The sun does work if the sun is 93 million miles away, and I don't know if you guys use kilometers, however many kilometers wide it is, 400, 800,000 kilometers. But the sticks and shadows argument also works if the light source is very close and very small. And you can do this with a shadow and a pencil all day long. So again, if you want to recite textbooks on what you think the sun is, and by the way, when you say you know what the sun is without actually going there and sending a probe and taking a scoop out of it, I would disagree.
So I guess this comes down to the fact that you are like a hard empiricist. Like you need to see it with your own eyes. Would that be fair to say?
Yep, absolutely.
You want us to actually cut through the earth and see a cross section, and that would be the type of evidence that you would take to be true. But I guess what's different about science is that we have this framework, which maybe we can talk about, where there are predictions other than the blatant cross-section, look at the cross-section. There are processes that would result from the structure underneath. And if you detect the structure, if you detect, these processes, then you can infer the structure from it.
Got it. I mean, if you want to go down that road, fine. Let's do your cosmology thing. Do you believe in dark matter?
I mean, dark matter in the sense of
I mean,
what?
do you buy into the theory? I mean, there are people octaves above you that are spending their entire lives convinced that dark matter is a thing, and they are going to go to their grave trying to prove it.
Right.
Well, we
so,
don't
But
know
in the
exactly
meantime,
what
they're
it is.
telling people,
Yeah.
they're telling mainstream media, it's like, oh no, dark matter, that's what makes up. I mean, they're stating it like an absolute fact.
So,
right. Like when we measure the content of the universe, we measure the content in several different ways. And what happens to be going on is that what we see with light is not what matches certain other data. And for the other data to make sense, there needs to be matter there, or something that is behaving like matter. So I guess dark matter doesn't really refer to a thing in particular the way the core of the earth is something that we refer to as a thing in particular. But it is some missing piece that we know has to exist. And that's what people are studying.
That's the point. It has to. You don't have absolute proof, but you're saying it has to exist.
We do
it
have
has to
proof,
exist because
though,
we see
because
it.
of
We
the
have
proof
that it's there.
We have proof that
you guys both
something is
believe in
there.
it. You believe that dark matter is absolutely a thing, and one day somebody's gonna come down the pipe and lay out exactly what dark matter is.
So one day someone will explain what the thing that is producing the anomalies in our data is. That's
Right.
what I will say.
All right. How about this one? Gravity, because that, when we're dealing with people, not you, octaves below you, that is the answer to almost every question there is, even though every mainstream scientist we have talked to, full-blown scientists, said, we can't tell you what gravity is. We can only tell you what it does. We can only tell you the symptoms of it.
That's not
I don't think
necessarily
that's true.
Really,
I
that's
think
Neil Tyson's words. I could give you a recording like right now.
is we
can't tell
know
you.
what it is. That's
Do
the
you?
thing. And the thing is, I almost feel as though, and I have this problem with mainstream media, which I think is why we decided that we would kind of start our own science podcast and whatnot, because there's a lot more science that the mainstream media is not talking about. And one of those things are kind of like the nitty gritty of what's going on underneath all of the, I guess, surface level popular science, I would say.
Is the nitty gritty what you may or may not introduce here?
Yes. So what it is that gravity is nothing more than matter deforming this space-time. It's not an attractive force that you learn about in high school. It's not like a little rope to one ball tugging on the other and the other ball tugging on the other with equal and opposite force that's proportional to their masses. It's not that. It is literally mass deforming space, and then just like a hill, things roll down hills.
So a massive object will deform space-time, and we have precise mathematical descriptions of how this works. We understand this well, how matter can deform space-time, and then objects simply move in straight lines through a deformed space. And if you move through a straight line in deformed space, that appears as gravity.
And by straight lines, it's I guess we should be clear that straight lines on a curved surface, or as Alex said, a deformed space, don't look like straight lines that you and I would draw on a piece of paper. And by straight line, in physics terms, what a straight line means is the path of shortest distance. So sometimes when the space is curved, that distance, the shortest distance, would look from a bird's eye view as a curved line, but really it just means the path of shortest distance. So that's what gravity is. That's the thing, is scientists know very well what gravity is. I really don't know why popular scientists don't want to say that. Don't feel the masses need or can know.
Because the textbook answer takes too long. And it's still sort of ethereal in nature when you're trying to, I know this is audio only, but it's tough to, but remember, you gotta remember who's out there. And I can't stress this enough. The average person on the street wouldn't have understood any of that. They would have absolutely lost it. In fact, they would have come back at you. In fact, even maybe a little bit smarter person would have said, can you show me something in a lab that reproduces this? Can you reproduce gravity in a lab?
You can.
We can.
Really? Because you're the first person I have heard in 6 years say that.
Well,
you
we
can.
We detect it with things
no,
like...
No, not detect it.
No, you can see it directly. You can show it directly with the Cavendish experiment. And it takes...
yes, the Cavendish experiment.
You can... And people have done this. And I mean, I'm sure that you have an alternative explanation. But...
Oh, you want me to give it to you?
Or do you? I'm not sure.
I think the Cavendish
would.
experiment is unproven. I think it is a failed experiment. Plain and simple. Because the Cavendish experiment wouldn't work the way you were hoping it would work, because you are supposedly on for the Cavendish experiment to work, you're supposedly on a ball that has its own gravitational force anyway. So how would it work? Exactly.
But we see it work.
But not
show me video on it after this is over.
Sure.
I want to see it.
Perfect.
Okay. I want to see it. I will show it to the community, and if they're convinced, we'll quit this whole thing tomorrow, which I would be unlikely.
Fantastic.
Yeah.
You know what I realized,
we'll
Mark?
talk about that more later,
we haven't even gotten into what are your views exactly.
Oh yeah. Sorry. Let's do it real quick. The short version: you are not on a tiny little rock covered in a little bit of water and a little bit of smoke flying through the impossible vacuum endless universe at velocities that are mind-boggling. And you're not an accident. You are sitting, I don't know, on a shelf. You're not an asteroid flying in space. You're not you're not Asgard. You're basically in a snow globe, a planetarium, a terrarium. You are in a building with walls and a floor and a ceiling, no different than a Hollywood backlot. And it is so big and engineered so well that even our best and brightest didn't figure it out till almost 1960.
So just to clarify, this was engineered before our time. We were put here.
Yeah, we had nothing to do with this. We didn't engineer this. This was engineered by an older civilization, much more powerful than ourselves, or some sort of deity, but then you're kind of splitting hairs. And what's outside of it? It's not space. In fact, we don't know what's outside of it. We've tried to bust through it for 4 years straight. The United States and Soviet Union tried to nuke the hell out of it. Couldn't get anywhere. And they kept it a secret. And why would they keep it a secret? Are you kidding? Civilization was already in place. The foundations were already laid. It's not what they stood to gain, is what they stood to lose. The only difference between you and me is that you think the Big Bang was an accident, and I think it was deliberate. How's that? You want to oversimplify?
You believe in the Big Bang?
Do I believe in the Big Bang? Sure. But I believe that it was deliberate and it was made much, much smaller. Meaning things came into existence, but you didn't need a universe to do it. Look, science tries
the firmament is some sort of like a dome that the stars rotate or something, or it's just a big projector? that
Could be either, to be honest. I mean, could be front projection, could be rear projection, could be a 1 million K HD system up there. I don't know, but it is so far above us in terms of
So
engineering. Sure.
that doesn't explain the motion of the stars.
Why not?
Because in the northern hemisphere, you can see stars. I don't know if it's clockwise or counterclockwise, but you can
And
see
when you
them
go down
clearly going in
Australia,
one
it's
direction.
counterclockwise.
It's
Yep.
counterclockwise. In the
Yep.
equator, it's one direction. You can't explain that on
How
a...
do you not oh, it's right. You guys don't play games. Do you guys play any games at all? Any simulations? It's called instancing.
Sure.
If you know software at all, and I do, it's something we've done for 20 years, which is called instancing, which means you can, the easy version would be you're in Australia and I'm in North America, and you see the belt of Orion and I see the belt of Orion, and you say, hey, the middle star is blue, and I say the middle star is red. Who's right? And it's of course turned the wrong
So
way.
everyone has their own individual perception of reality. So
it doesn't have
my
to be
projection is
it doesn't have
separate
to be
yours.
necessarily individual, but it could be regional. I mean, that's how we trick people in the virtual things we create now.
So the deception is going on to some extent. It's going on inside our brains then.
Some of it, sure. Why this shouldn't be too much of a stretch for you guys. I mean, you guys were the guys that came up with the whole virtual reality concept.
If I have a certain instance of the sky, okay,
Yep.
I see things a certain way.
Yep.
And you're saying that someone in Australia is a different instance, okay?
Yep.
So then if I travel and I'm continuously looking at the sky the entire time that I travel down to Australia,
Yep.
okay? So I never take my eyes off the sky. By the time that I get to Australia, my friend in Australia is looking at the same patch of sky that I'm looking at now. Are you telling me that we're going to see two completely different things?
Dun, dun, dun. Possibly. Yeah. Very, very possible. Why not? I mean, first, it's never happened. And that's one of the most original things I've heard in probably 6 months. So pat yourself on the back for that. It's never been tried. It's never been, but theoretically, yes. Yeah.
Shifting topics a little bit. What testable prediction of flat Earth theory could I propose to you that if I prove flat Earth theory wrong, what would change your mind?
That is, by the way, the first time anyone has ever used those words. When choosing, it's like normally, again, remember who I usually talk to. It's like, what would I have to do to make you quit flat Earth tomorrow? It's a good question. One of two things. First one would be difficult to do because the cost or the permission involved, and that is get any sort of decent camera, strap it onto any capsule of anything, point it down at the ground, don't point it up, and let this baby, and something that's going to leave orbit.
Well, we don't believe the images from SpaceX or NASA, or we don't believe any of those, do we? Or Virgin or Boeing, all of their flights.
Oh, I will. You know what? Just for that, let me see. Just for an example, look at that picture, by the way. The longer you stare at it, the worse it gets. And again, I'll give you the real simple
Tell us
stuff,
about
right?
the picture.
Forget about no stars in the background. I don't care. People are going to say exposure settings. I don't care about that, even though there's no stars in any photograph ever. 3 quick things. One would be if there is a light source that's 93 million miles away and there's only one light source, all the shadows run what? Parallel. Thank you. Oh, that's the problem. None of those
Sure, I mean,
shadows.
this is taken with a very wide angle lens.
No, but when that's going to explain the shadows running perpendicular, they're going to intersect. Those shadows are all going to intersect. Fine. If you don't want to look at that one, by the way, no one's been able to answer that ever. That only happens if there's a light source 30 yards behind them.
What if this was a panorama and it stitches things together at inconsistent angles? Like, are you sure? Like, how are we sure that this
straight off the NASA website, date and time stamped?
Sure, but
what
we
Hannah's
don't know
saying,
if this
if you
was
take
multiple images stitched or not.
Okay, I'll give you another idea though. If, as you say, there should be a light source 30 meters behind or whatever, then the shadows would be going outwards, not inwards.
Not necessarily.
Why not? That's how shadows work.
Look, studio lighting you can do just about anything you want.
But I only see one shadow.
But in this case, the shadows will not. Doesn't matter. Do not go that way and say they're going to go out instead of in. The point is they should be running parallel. Second point, ready? You see all the footprints. This is a great image, by the way. All these
Okay.
footprints, by the way, perfect uniform 3-inch, 4-inch ash around everything. I always thought that was kind of strange because no one was in a shovel. It's like, what's underneath that ash? How deep is the ash? Is it only 3 or 4 inches? Perfect, which is what you would do in a studio. Footprints everywhere, right? Can't miss them.
Okay.
What's missing in that shot? See it? Anyone? How about the blast crater, the splay pattern? That's a 10,000 pounds of thrust American engine under that thing. There should be a huge splay pattern.
There's
In
no
fact, there
wind.
shouldn't be any ash underneath that thing at all.
There's no wind though. You wouldn't.
No, it doesn't matter with the wind. The thrust itself would have kicked out the ash. Don't give me this wind thing. Come on, man. The thrust would have knocked the ash away. It would be nothing but rock underneath.
Not necessarily, because the reason that thrust knocks things away is because you have an air current that's pushing things out of the way. It's the air that needs to get out of the way and therefore pushes things
If you're going to go in that direction, then I would counter with this, which is my point.
Okay.
When we're swimming, our arms push against what? Water. When we're walking, our feet push against the ground. When a plane is in the air, it pushes against the air because what we're breathing in here is just this soup, nitrogen and oxygen. When you're in a vacuum, what's it pushing off of?
It's not pushing
Momentum.
off of anything. What it's doing is it's propelling. No, it doesn't have to. The thing is, no, it doesn't have to, because what it's doing is it's burning fuel. The fuel is being shot out one direction, and by Newton's third law, you then get propelled in the other direction, because equal and opposite force.
You can do this experiment yourself if you sit in a rolling chair. If I right now in my chair, if I have a bowling
you're
ball
not in a vacuum.
and I throw a
Not
bowling
in a
ball
vacuum.
forward, if you don't need to be in a vacuum.
Even more in a vacuum. You notice these
it's
effects
even
even
more
more
so.
so in a vacuum.
I'm sitting
Offline,
in a chair.
I can show you tests in small vacuum chambers where little rockets don't do anything in a vacuum chamber. They don't do anything. But again, let's circle back. If you want to say, again, if that's your answer, but you're the first ones who have even answered this, or even tried to answer this. Last but not least, the satellite dish there that you're seeing is not secret technology. That is a VHF transmitter. It is running off a car battery.
Okay.
That thing has a range, maybe on a good day, of 50 miles. And that's Morse code, if you're lucky. I mean, if I drive an hour from here, I lose cell signal. This thing is running off of no power whatsoever. It's not running off this massive generator. If you want to say it's relaying off the thing that was orbiting, that's fine. What are they bouncing off of? There's not enough power to send a signal. And they're supposedly pumping out 10 frames of color video a second.
But it's not about the overall amplitude of the wave that they're transmitting. It's like, for example, if they're transmitting, I guess, okay, let's do the car example where, you're in the car and you're driving in downtown of a city, and you turn the corner and you're suddenly between a bunch of buildings and you lose signal, right? Like the reason why you lose signal there isn't because there isn't enough power in the signal. It's because you've had interference, but there's no interference in space.
So if you're in a flat vacuum of space, for example, I shouldn't say flat, when you're in a vacuum of space and you just send a signal, then it can travel forever and ever and ever. And that's why we see stars so far away, because there's electromagnetic radiation coming from those stars, which we see as light, by the way. Light is electromagnetic radiation, and that travels forever and ever and ever for billions of years until it reaches our eyes.
A perfect textbook answer. Okay, let's move on to another one.
Yeah,
Sure. Let's move on.
I got nothing left to look at. And then all of a sudden I saw this and I thought, okay, flat Earth is stupid. It's ridiculous. I really thought I could shut it down in about a weekend, and that's how everybody gets into it. And I'd really like to clarify is that nobody likes flat Earth, especially when they first get into it. Everybody hates it. It's just the most unpalatable thing you could ever think of because of the conditioning we've had. That globe that's behind you, that's been sitting in your classroom forever. I mean, that's very, very strong reinforcement, and that's just a little toy globe. And so I kind of treat it like a court case, and I don't know if I said this in the documentary or not, where I treat it like, could I prove the globe in a court of law? Or was there reasonable doubt? And so, to your science friends, it's like, can I prove to you the flat Earth? Can I prove this thing? Nope, can't. Can I create so much reasonable doubt in the globe, to the common person, not you guys, that the only place you have left to turn is something like this? Yeah, I can. I can do that all day long. And you say, well, and again, that's where science braces. They go, no, reasonable doubt's not enough in science. I go, well, no, not in science. But in the rest of the world, it is. Reasonable doubt wins every day, every hour in court all day long. And that's how it started.
One thing that you said in there that I actually really, really, really love. You said that, can I prove the flat earth? No. But can I show you things that make you question the globe earth? Yes. And you know what? I love that because that actually sounds like science to me. You know, science.
I don't hate science. No, I hear you. I taught proprietary software for 20 years. It's not, look, I was a big tech guy. I loved science. But what I started to figure out was, again, no, not offending any of you guys, is that science tended to take leaps just because they could.
I have two questions here.
Sure.
A, why do you think all of these doubts that you have, all of these plot holes, as you call them, for a globe earth, why do you think that scientists never found them before you? And second of all, why do you not do the same with plot holes when they're found with the flat earth model?
Oh, no, we do. We hammer, that's just it. We know everybody goes into the flat earth trying to debunk it. There are dedicated trolls now that with channels just every day trying to hammer this thing out, and they're not convincing anybody. Because, and it was talked about in the documentary, you may have missed it, which was the reason why our retention rate is so high. It's like once you get into flat earth, it's like a 99% chance you're not coming out of it. Why? Because I didn't convince you. I didn't persuade you. You convinced yourself. You guys wouldn't because you're in deep. But
what
the
does
average
that mean,
person,
I guess, can you explain that maybe? Like, what does it mean to be in deep?
Because we want to be wrong as scientists, you know? We
Right.
want to be wrong about our theories because that's
but-
how we progress. So
but
why would we not want to tear away our own theories?
No. Well, it's not that you don't want. It's nothing to do with wants. It's that, and I said this, look, if you have a master's degree in any physical science or higher, I joked about this years ago, then you're probably not coming back because you were so invested in the financially, the time spent, not even emotionally, but you're so invested in it that the paradigm shift would be too much.
But do you think we're lying, or do you think that we are just...
No, I don't think you're lying. Not at all. You firmly, absolutely. If you gave both of us lie detector tests, we both pass.
You've like alluded to this several times. Is you know, there's regular people,
Yes.
and they can't believe in science, or they can't really understand what science is really because science is overcomplicated. It's too complicated for them to understand. But on the other hand, there are a couple people who have decided, you know, like, I'm gonna do this. I'm going to put myself to this challenge and I'm going to go and learn and understand it all. Like, it's not easy. I guess, let me put that out there. It's not easy to learn physics. Like, it's really hard.
No, it is
so
not.
Hard. I don't know if you should assume that, like, people are too dumb to ever understand physics. Like, why should we make people settle for the flat earth because we don't have faith that they can learn the real physics that is required to fully understand all of the globe earth? Like, just because something's hard to understand doesn't mean it's not true.
No, you're absolutely right. But it's the first part, but it's still hard to understand. And I've made this plea to science for some years now, which is, look, until you come up with, and it is the blessing and the curse of science, which is you get to a certain point and your thought patterns and all the work and time and yes, you focused and you've got it. The problem is when you reach that point, you don't want to make it available to the common man. And maybe want isn't even the word. You're not going to, because the reason why your friends aren't here, it's beneath you. Well, that's a problem because the masses, all the people that weren't in physics club or math club or chess club or any of the other clubs, is because they barely made it through school. The masses are a huge group. Mm-hmm. And they want something that's easy to understand, which is, again, why I put it out there. I go, look, if the globe wants to fight against flat earth, great. You know, the heliocentric model wants to fight against flat earth. You better come up with some Schoolhouse Rock version of it.
You were saying that we as scientists should be able to make an easily digestible version of our science for everyone to understand. But what if you have something that's just inherently difficult to understand? I mean, why does something have to be easy to understand to be true?
Just because I don't get it, that's kind of Neil deGrasse Tyson, isn't it? It's like, science is true whether or not you believe it or not. What your version would be, science is true whether you not you understand it. It's like, maybe,
I mean, I
except that
guess it's the same kind of thing as like a tech product, right? Like your computer. I personally am not a computer hardware engineer. I don't know what's in my computer that's making it work right now.
sure.
Just because I don't know how it works doesn't mean I know it works.
She's sitting on a really good point. I mean, you trust medicine, you trust airplanes, you trust cars. We don't know the exact science behind those, but why do we trust those and not other
Well,
parts of
but
science?
we know actually quite a bit. You got to remember, there's a lot of blue collar people that work in the automobile industry, not necessarily in the engineering side,
Mm-hmm.
but everything like the phones that you use were just an evolution of the early PCs. We just made them smaller and smaller and faster.
Mm-hmm.
Um, but again, they were a hands-on type of deal. Now, if there was a box, a magical box that did something that we just found, and no one could explain how it worked, but we just, it's kind of, I'll show you. There's a quote I had. Sometime I've said this way. I've never said this on air, which is, science is just magic without mystery. Meaning, it is once it
I
became
find that concerning,
repeatable, science put their stamp on it, and then that was it. And it was like, oh well, as long as we can repeat it, that's fine. But when the general public can't, when you're talking about things that are outside our world, things they can't get a hold of, they have a tough time with it.
It's
They have a
funny,
tough.
Mark, because you say that science is magic without mystery. I would define science as mystery without magic. I mean, these are things that we
I like
look at
mine
these
better.
crazy things happening in the world and our minds are blown, but we can learn, we can appreciate to understand these things very well and know how they work.
But
There's no magic going on.
they start out as magic, meaning that science
They start out as
something that
mystery.
they turned it from something that was absolutely incomprehensible into a solvable mystery. How's that? Is that a little better? Solvable mystery, maybe. Don't take anything completely for granted, because again, there are people out there that will do things for ulterior motives, and science is not incorruptible.
The amount of people that have to be in on this conspiracy is ridiculous.
No, absolutely not. Very, very few people. This is one of those things you normally would be right. This isn't like the Manhattan Project, where you have people refining things in 3 different parts of the US and you keep the whole atomic bomb secret. This is where the only people that have to be in on it, honestly, are the software guys, the telemetry guys.
Well, I don't know. I mean, you do need people that, for example, everybody that works on the satellites, that people like at Google, at SpaceX, that also work on satellites. I mean, how would satellites work? They all must be in on the thing because they need to take into account things like special relativity and the curvature of the Earth and how they map where the satellites are around the world. I mean, these all depend on a globe model. Not only that, but what about, like you're saying, I don't know, pilots that fly through the southern hemisphere, or weather stations, meteorologists, people in shipping companies,
Nope, none of those
FedEx,
guys.
DHS.
Nope,
None of
none of
those
them.
people.
Nope,
None of the
no. In
people that I
fact,
mentioned.
this is one of those things you would the less the amount of people. What's the word I'm looking for? Less is more in this case. You do need to know. There's no better example of need to know than this one is.
My opinion here is that even if it were on a need to know basis, science, physics, technology, it wouldn't work as we have now. I mean, physics as we understand it now is such a self-consistent theory. You can't have some parts that work and some parts that don't. If this whole theory were built on a lie, then you're talking about somehow the government would have had to come up with this incredibly detailed, incredibly self-consistent theory that explains almost everything in the universe as we know it today.
What
And
universe?
well,
I
everything
guess
that we
Again,
see,
I mean,
everything that we're able to
if
observe.
it's just lights on the ceiling, then what universe are you talking about?
Well, I guess, okay, here's a question, I guess, off of what Alex just said is, there's this giant conspiracy, there's stuff that governments want to hide, so they start, proposing this globe Earth model to hide it. And they're trying to hide it from who? From the masses,
Sure.
like you said.
Sure.
And you also said that the masses can't understand complicated things. Why would they have not chosen something easier to understand than physics, which is so complicated? Why would they choose that?
You mean, why would they allow physics to happen?
Yeah, why would they allow, like, is physics fake, I
because the
guess?
people that run. All right, I will speak this as a government agent. I will throw this out at you. What do we do with the uber nerds? No offense. What do we do with you guys? Well, just let them run with it. Let them come up, because they're going to argue about all sorts of theories for the next so many decades anyway, and the general public's not going to understand any of them. So let them publish their papers. Let them get their PhDs. Let's go. In fact,
But the thing is, Mark, that doesn't work, because the PhDs that have been published would not have worked under a flat Earth model.
Again, what do you think the flat Earth model is? Meaning, we just say whatever's in the sky is in the sky. You guys are the ones that define it. If you want to define it, you can define it any way you want. You want to alter the speed of light? You want to talk about space-time curves? You want to talk about wormholes? You want to talk about all the other Star Trek-y stuff? Fine, go ahead. It doesn't change our view at all.
So I feel like at the core of this issue, it's not a matter of, we don't necessarily disagree on what we see, but we disagree on that scientists or physicists, we want to find a self-consistent theory to explain things as we see it, whereas flat earthers, and correct me if I'm wrong, but you guys want a easily digestible idea that can be reduced down to, we don't understand things and that's just the way it is, and maybe I see things that are different to what you see and we don't need to explain it further. That's kind of
change. Yeah, something. It's kind of a long-winded version on your side, but my side is this: we turned the universe into a studio apartment. That's all we had to do, and for everybody in our community, it works just great. And again, because it's easy to explain, we think it's easier, and that's just what we go with. But yes, yeah.
So okay, I'm familiar with certain experiments that flat earthers have done where you see further than you should, basically.
Yes. Yeah.
But you don't see all the way.
Why can't you see Japan from California? Why can't you see Mount Everest from everywhere?
Sure. Or why can't Mount Everest? Yeah.
Come on, you know this. Come on.
I mean, I know what.
The atmosphere's too thick. We're breathing in, again, I'm not picking on you. The average person doesn't even know what we're breathing in right now. We're breathing in 80% nitrogen, 20% oxygen. Yeah, I know there's some trace gases. I'm just rounding up on both sides.
Okay.
Which means there is a thickness to it, which means it's only 99% transparent. No different than water. If you go diving 200 feet in a summer day, you will lose the sun. It's gone. Why? Because the sun rays cannot penetrate the water. We're basically living in a thin version of water.
Well, that's not true, because you can see the sun coming through the atmosphere. You can see the light from the sun coming through.
It has to pass through the whole atmosphere.
Yeah, that's my point. The point is the sun doesn't set. It just fades off in the distance. If you had a filter and zoomed in with your cameras, in fact, we can pop the sun back up. You can watch the sun set. You crank up the zoom, it pops back up. You crank it up, it pops up again. And then eventually it just fades away into the soup that we're living in right now. And we can see this with just about everything.
I don't think that's true, to be honest.
It's not true. I've got how much.
I would love to see that video. You can send it to me after.
Again, this is cognitive dissonance right here. You don't. Here's the difference. You don't want to believe it, and I don't blame you. I don't. But again, you want to know why our community just keeps trudging on like we're doing? That's the reason. It's because I didn't convince them to do
I'll tell you what. I have seen explanations for why the sun supposedly sets, and I want to know if this is one that you believe. They believe because as the sun goes far away, you should see it just getting smaller and smaller and smaller and smaller until it's a point essentially that you can't see anymore. That's not what we see. Okay, we see that it literally goes below a horizon. Okay, and the explanation for that's on YouTube is that supposedly the atmosphere is like a curved lens, and therefore it appears that it's setting even though it's just going.
We didn't come up with this term, by the way. It's called atmospheric lensing. Mm-hmm. And meteorologists, I know it's not your field, meteorologists came up with it, and I didn't even know it was a thing. You can make, in fact, you can make a flashlight set on a perfectly flat table with a glass of water in front of it.
Sure, and this is exactly what I wanted to bring up because that doesn't
The flashlight didn't
work.
set.
No, so it works with a glass of water, sure, but the atmosphere is not a glass of water. And so
It
yes,
is.
there is this thing. There is
It
this thing
is
called
a glass
there
of
is
water.
this thing called lensing. You are correct about that. But so the extent to which this has an effect does not explain a setting sun. Okay,
Sure
these
it
are
does.
very measurable amounts of things that you can exactly predict how much a light ray is going to bend. It doesn't explain why the sun would set. Second of all, it's
It would if
the
the sun was
reason
50
why
miles
the
wide.
reason why light bends is actually due to the curvature of the Earth. Light bends when it goes through varying densities of air. Okay,
And yet when we do
if
laser experiments, the
if-
laser doesn't bend.
no, that's not what I'm saying. I'm saying that if the Earth were flat, so if light was just traveling in a straight line on a flat plane, then there would go through no changes in density and it would never bend. On a round Earth, however, when it goes through parallel to the Earth, that's when it's traveling through different densities of air, because now it's all of a sudden traveling through different columns of air, because straight line and a curved line do not they don't match. So that's when it's going through different densities, and that's when it bends.
A perfect textbook answer.
You don't have bending on a flat surface. And I'll tell you even a third point is that sometimes atmospheric lensing curves the other way, and that's when you see things like mirages. Things are bending the other way. So there would absolutely be times where we should see New York, because why wouldn't it bend the other way? You can have fluctuations in density, temperature, pressure, whatever.
The only way you could ever see New York on a flat surface is if it was a pure vacuum. I want to throw this at you because I know that both of you want to address this one. Gravity versus the vacuum of space. If you had a vacuum chamber above you in your second floor of your house or apartment or whatever, and you have a valve and you pop it, what's going to happen? Well, it's going to be instant equalization. It's going to be violent. It'll be a fraction of a second. It'll be horrible, right? The question is, why didn't gravity keep the air in your room instead of firing it upstairs? Why? Because vacuum will beat gravity every single time. You can do this with a straw and a glass of water. It's very, very powerful. So the question is, when you go outside, why is our atmosphere still here? Is your answer gravity?
Mark, to be honest, there are gases that do escape.
Yeah, there are definitely things that escape. Like there's
why
no
doesn't
question.
everything? No. Why doesn't everything escape?
Well, where did
Knowing
the atmosphere
what
come
vacuums
from?
can
The
do.
atmosphere. Well, where did the atmosphere come from as well? You do know that these gases, where they come from, is that so we are in a process of equilibrium right now, right? So we lose gases to space, absolutely, at a very slow rate because gravity is strong, okay? But we do lose gases to space at that outer equilibrium, like you say. But we're also getting gases from space from things like meteors and asteroids, and when things collide into space, they are vaporized and they become gas. That's how the atmosphere got
So
here in the
there's
first place.
no other possibility. There's no other answer. That's got to be it.
Well, it's well
not
understood.
Not that we're living actually
it's well
in a
understood,
pressurized
and
system.
we see this. We see
Doesn't-
this,
doesn't
for
the term,
example,
by the
when
way, doesn't the term greenhouse gases mean? Doesn't it make more sense if it's an actual greenhouse? Doesn't it? If it's an actual physical barrier that you're inside a building?
not necessarily, because we also understand well how those greenhouse gases trap.
And those greenhouse
radiation.
gases and all the other gases, they don't get ripped off by the biggest vacuum of all time.
Well, that's what I was saying. So they do slowly get ripped off.
Why
but
slowly?
Because gravity is quite strong. But
Nope.
like I'm saying, it does happen. Gases are lost, but we're in a state of equilibrium where we're getting gases from things that are coming into the atmosphere and getting vaporized.
I agree that gravity is definitely the dominant effect of why the atmosphere is on
Has
the
to
Earth.
be.
Like, I think there are contributions for like ionized particles, like why ionized particles stay within the Earth's atmosphere. Like I think there are electromagnetic interactions which keep things together. But the thing is, I think we need to understand that gravity is it's a force of scale, I guess. I think people underestimate how gravity is actually the weakest of the fundamental forces of nature, but it acts on the largest distances. It is the weakest, but it acts on the largest distances, and it can very quickly beat out other forces of nature very quickly. So the reason why, if you're in a room and you have one level of your house that's a vacuum I think this was your example.
Sure,
You have
from
one
just
level of
vacuum
your,
chamber above you.
you have a vacuum chamber above you, and you pop it, and all of the particles go into thermal equilibrium with the vacuum and
Yeah.
spread themselves out homogeneously over that space. The difference in gravitational potential between where they used to be and where they go just above you is like is probably unmeasurable by our best instruments. Like, the difference in gravitational potential is so different that thermodynamics wins in that scenario. But when it comes to the entire Earth, gravity wins every time.
Well,
Gravity
again,
wins at
from
that
your
scale.
from your side, it has to, because it's the only explanation.
I mean, it doesn't have to, but it
Oh,
just
yeah, it
does.
does.
If you do out the math, if you write it out and you do the calculation, it does.
Here's another thing that I think we're forgetting about, that right now, if we're doing this experiment at ground level, there is pressure from all sides, okay? The reason why the air will rush upwards is because there is pressure acting on the air in every single which direction. It's acting up, down, sideways. That's why it's an equilibrium. The moment that you take out some pressure from the top, and that's what happens in a vacuum, there's no longer pressure coming down from the top. That's why the pressure coming from the bottom overwhelms it and will push the air upwards, okay?
And
If we're now at the top of the atmosphere, there's very little pressure, okay? Because there's so much less air being pushed down upon it. So this atom at the very outer edges of the atmosphere is not being pushed up, down, sideways, in any which direction very much. It's really not being pushed around. So the dominant force acting upon it is gravity pulling it down, and that's why it tends to stay.
You're reaching. You put a basketball in a vacuum chamber hung by a thread, it's going to expand uniformly until it bursts.
Well, no,
And that's a vacuum coming in
there
from
is
all
pressure.
sides.
But because we're doing it in an environment in which there is pressure, as soon as you take pressure out of the equation, we're not going to see the same effects.
Why would you take pressure out of the equation?
Because we're in the upper outer atmosphere
There's still
where we're
pressure.
in a vacuum by nature.
It's just much less, but that's not the point. Shrink the macro down to
But
the
that
micro.
is the point, Mark. That's exactly what I'm saying, that the same experiment is not going to have the same result down here versus up there. Down here, you have significant pressure pushing the air upwards when you remove the vacuum. In a vacuum, practically, the top of the atmosphere, you don't have that same pressure acting on the particles, and so it is not going to explode upwards into the vacuum because you don't have that pressure pushing it outwards.
You're thinking too small. Think this. In fact, let's go the other way.
I feel like you don't want to accept my explanation, Mark.
I know you don't want to see it. I know, trust me. And this is why I say it is tough talking to you guys sometimes, because your minds are already so far down that road. You're not coming back. But that's okay. I don't blame you. It's okay. Anyway, thank you guys.
Thank you
for all this.
Thank you so much.
No worries at all. No, it was I am grateful to you for at least getting this far. Seriously, your friends can suck it, because they should have been here.
Honestly.
They can. Because
Gungeon.
well, I mean, but then again, that proves the point, which is like, look, it's so tough to get serious academics, which you guys are, to even engage in it. And good for you that you did. I know that other people, people are listening, probably going, "Oh my God, he's insane." But that's fine. It's we differ. I'm hoping the gap can be bridged one day. We'll see, one way or the other.
I hope so too.
Thanks, Mark, for talking to us. I know that it might have been, I see why you might not be, willing to talk to the scientific community after, how they tend to treat people who believe in the flat earth. But as a scientist, I feel like it's my job to talk to everyone, however crazy their beliefs might seem to me. And so I will always be willing to talk to you and people in your community, because as a scientist, that's what I've pledged to do. I've pledged to teach people what I want to know. I'll extend this to you as well. Like, if you ever are interested in learning some science or want to see what a physics department looks like, I would be happy to show you, like, up close and personal, like what it is to do science. And I hope that it can, like, we can learn from each other and maybe,
thank you. That is a lovely offer. I don't know if I'll be allowed to do any international travel.
Yeah, that's the issue. That's the issue we face right now. But
we will
see. Canada seems to be an off-limit zone at the moment, but we'll find out. But thank you guys very, very much. And if you need any other resources, feel free to shoot me a thing.
Thank you, Mark, for being here.
Yeah. Bye, guys.
Bye.
Bye.
There is no single cure to combat science skepticism, and we don't know what the cure is for this. So I was thinking that's why we need to have open conversations as scientists with these people, with these science deniers. And when you don't know the way forward, maybe it's best to sit down and have a conversation about where you're going. And I think the takeaway for me today was when Mark was saying that we want things to be easy. We want things to be easy rather than difficult to understand and difficult to digest. But why do things have to be easy? As science gets more and more complicated, we want things to be digestible, but maybe they're just not. And maybe they don't have to be, and maybe that's what we should be thinking about.
I completely agree. Yeah, that really was off-putting to me when he said that, because it made me feel like what he was doing was just trying to sell the masses some easy way out to understanding their purpose in life. It made it sound like Flat Earth was really just like a religion that they were trying to, sell to people to make them feel at ease, like they could understand the world they live in. Another thing that was upsetting to me was when he said that scientists were not willing to talk to him. Like, scientists were not willing to debate with him ever, or rarely. That's not how we solve this problem. If people don't believe in science, the solution is not to alienate ourselves even more as scientists. That only confirms their belief that we are hiding something. I'm becoming a scientist not just to discover things for my own vanity or anything like that. Like, I want to teach people science because it changed my life. And when I say teach people, I mean everyone. And whether you like it or not, science deniers are included in that everyone.
I'm with you on that. And on top of that, that we also have a responsibility to show that science by nature is not easy. It's not something that you're going to be able to digest just by watching a 5-minute YouTube video. The universe, Mark doesn't like that term, but the universe by nature is fundamentally complicated. And we are kidding ourselves if we're going to be able to understand it, being one person. So maybe we should be clear with that. Things aren't easy to understand, and that's okay.
Yeah. We'll see you next week, hopefully with Gunjan and Trevor next time. And yeah.
Bye. Thanks for listening to our podcast this week. You can find us on YouTube, Beyond the Big Bang. You can also find our podcast channel on YouTube, Beyond the Big Bang Podcast, where we post clips from our podcast just like this week. And feel free to find us on Instagram and Twitter too. You know the handle, Beyond the Big Bang. We'll see you next week.